Hi everybody, welcome to this video. Today we're going to talk about complex Kubernetes scenarios. My name is Alex Buisine, I work at Enix and we are in partnership with OVHcloud, so we would like to demonstrate what we can do as partners here. Let's get started. As an introduction, it's pretty usual to face Kubernetes managed solutions, but sometimes they are not sufficient, and in such cases you might benefit from additional expertise and experience. So in this presentation, I'm going to talk about first fully managed clusters, but with a little difference of having the application being managed as well, and also about very specific implementation of Kubernetes. So we're going to go through 3 real-life use cases, see the attached challenges, and how you can address them. Very good examples of typical difficulties. First one would be budget and capacity planning. You never know how many nodes, the size of the nodes you're gonna need for your production. It's also difficult to decide between keeping your Kubernetes clusters on premises or moving them to the cloud. There are some typical pitfalls. Sometimes you want to integrate your existing infrastructure with the clusters you have around. Security matters. Down on the way on day 2 operations, you might realize that your continuous integration and continuous delivery is not efficient enough, so you will have to review them. And then it's also pretty usual to review development methodology, in particular the observability of your application, so that you are not facing in production very big problems or outages that could last several hours. So that's pretty much it for the introduction. All right, let's talk about the 3 use cases. They are all 5 minutes long, so you can stick to another part of the video if you don't want to go through all of them. The first one is about migration from on-premises to OVHcloud, and I mean Kubernetes cluster. The second one is about a very specific Elasticsearch cluster that the customer wanted to be fully managed. And the third one is about day 2 operations within a mission-critical environment with very big service-level agreements. So let's talk about the customer in this first use case. The client was quite comfortable with containers, but was only discovering Kubernetes in development. They realized they were not experienced enough to deal with production. They were launching multiple instances of their application, so on-premises, on dedicated bare metal machines. And they envisioned Kubernetes as a way to cut costs, to minimize their infrastructure. They wanted to mutualize resources, CPU, RAM, storage, etc. They were also interested into having a better time to market, meaning being able to ship faster and more often. So let's go discuss about our approach. First, we made sure that the customer was comfortable with Kubernetes, basically, that they were understanding the difficulties, were able to play with it, and were sufficiently trained so that they could deal with the production. The second part was about transitioning their software to cloud native software. So the simplistic way to talk about this is to talk about generic containers, simplified configuration, and making sure that you have some observability. The third aspect was about building an hardware capacity plan, so making sure about what we would need in production on OVHcloud. And finally, ensuring the connectivity between what was stuck on premises and what was moving to the cloud. So first challenge was to build up the team around Kubernetes on the customer side. We trained the whole team, but we especially made an implementation around Slack, so building dedicated channels and staying close to the customer during the migration, but also most importantly, the weeks after, the month after, so that we were able to adapt with the customer what was not running smoothly, and making sure they were also, complete a bit the training and making sure they were comfortable with day-to-day operations. The second challenge was about the network extension. As I said before, some critical stuff were left on premises. So we had to interconnect the existing on-prem infrastructure to the new one on OVHcloud. We had to build up VPNs and ensure the connectivity, layer 2 connectivity between the on-premises and the OVHcloud. We also implemented the ambassador pattern, which is basically building avatars of the critical database or user credential solution within Kubernetes. It made all of the software inside Kubernetes aware about something that is not locally present in the Kubernetes cluster, but remotely present in the, stuck in on-premises. Second challenge, the second challenge was about cloud native principles. So we had applications that were already running in containers, but obviously they were not ready for Kubernetes in production. Why? Because most of the Docker files were not really generic. So, some Docker files dedicated to development with all of the debug flags, etc. The configuration was a bit messy, so we had to simplify it and make sure that all the Docker images were very generic and simply configurable. We also had to went through all the M charts and making sure that we were not dealing with complicated stuff where it was not needed. Especially here, we had to change a bit the resources that were used, as not all the software could run as deployments, obviously. So as the results were pretty interesting. The first stuff is that we divided by 5 the infrastructure. Sorry, it's better without the webcam. So as I said, 80% of the infrastructure was basically destroyed and replaced with only 20% stuff on OVHcloud. We consolidated 9 instances of the application, which led to almost 50 deployments in the cluster, plus stateful sets, etc. We had 5 persons fully trained, and also we were pretty fast regarding this, as the first POC was delivered within a week, which was pretty important for the management, and we finalized the migration within a month. So within a month, their application was running on OVHcloud, and they were already having benefits. That's it, I would say, for the first use case. Okay, let's go through the second use case, which is about Elasticsearch with a fully private and managed cluster. So in terms of the customer was pretty used to Elasticsearch in general. They were running a bunch of clusters, and for this particular project wanted to add additional plugins like machine learning and security related ones like Wazoo. They didn't have the time to hire additional people or to train the existing one, so their strategy was to outsource this project to us, and at the same time they wanted to keep total control and ownership over the data that was running through the cluster. So in terms of our approach, we reviewed all of the existing Elasticsearch clusters as well as their additional requirements for this new project. We selected the right architecture, which was ECK, simply for Elasticsearch over Kubernetes, and then had to choose the right bare metal devices. So within OVHcloud we chose the HD1U. These devices were used for the worker nodes, the one that were running Elasticsearch, but we kept the control plane and master nodes
on standard virtual machines. So all in all, we had to design the architecture, implement it, and then operate it, and we're still operating the cluster today. In terms of challenges, the first one would be related to the ingest pipeline. A typical architecture with Elasticsearch is to have bits agents sending messages to a centralized Elasticsearch cluster. The customer wanted to add two additional functionalities to this: the possibility to do maintenance on the cluster without losing any kind of message, and also the possibility to replay some of the messages if a mistake was done on the Elasticsearch cluster or an index configuration. So we implemented an highly available Kafka cluster, which means that we had to implement Zookeeper as well. And this led us to have this always-on buffer mechanism that allowed these two functionalities. Second difficulty was regarding performance and capacity. So the numbers of messages, 3 to 4K per second, is pretty low from an Elasticsearch standpoint, but the data retention required and the numbers of queries sent to the Elasticsearch cluster was pretty high. So we needed a solution to handle such performance requirements. Our strategy was to implement local drives, local NVMe drives attached to the bare metal devices. This allowed us to have the best performance available on the market, basically, with massive IOPS and large capacity. And in order to connect this local capacity to Kubernetes, we used Topo LVM, which is one of the strategies available to have persistent volumes using local storage. I could talk about local path provisioner and that kind of stuff also. Other options may do the trick, but we choose Topo LVM in order to keep native performance and quota management. The storage might be quite tricky for some of your other projects. I just wanted to emphasize the fact that OVHcloud can propose large numbers of solutions in terms of storage, but especially it's possible to attach 1 to 4 physical hard drives to your bare metal devices. And that's clearly something that is a big plus when dealing with such scenarios. So in terms of results, we had finally 200 hosts pushing messages to the Elasticsearch cluster. This multiplied by 4 bits agents per host, including file bit, metric bit, audit bit, and WASU. This represented 100 gigs of log per day, which is not very huge, and 3 to 4K messages per second. And overall, the data retention required 30 terabytes of capacity. Okay, that's it for this second use case. I just wanted to state that apart from Elasticsearch, we are pretty used to dealing with other kind of clusters, SQL databases, NoSQL ones, buses, etc. So feel free to contact us at KubeCon if you want to discuss about this. That's pretty much it for our second use case.
Okay, let's talk about the third use case, which is about day 2 operations while dealing with complicated Kubernetes needs and environment. So the customer recently moved from .NET Framework to .NET Core in order to launch their software inside containers running on Linux. They were already operating Kubernetes, but they were dealing with their historical code, which was an application that was connecting to third data hubs, and which was pretty sensitive to a network latency. This was run through several regions around the globe, was highly available 24 hours per day, 7 days a week, and with significant loss of revenues in case of any outage. The application was at the same time a singleton, meaning that it was not possible to run 2 instances of the app, not possible at all, very dangerous for them. and also they were stateful, and they were producing files on a local file system, which was quite problematic to deal with. So our approach was to review their existing containers, continuous integration and continuous delivery, as well as adjusting the resources they were using on Kubernetes. When you're dealing with such applications, obviously you don't want to use standard deployments. We had also to implement a bunch of missing bricks in their production, as they were not using unified authentication. They didn't have centralized logging. They didn't have metrology monitoring for their application, and they were not using the typical ingress stuff with TLS enabled everywhere. In terms of challenge in this project, the first one was clearly all of the different locations we had to deal with. I mean, this application, dependent on very low network latency, required us to deploy a bunch of nodes on different OVHcloud locations. We had a long discussion about do we implement various Kubernetes clusters everywhere, or do we have a more single approach with remote worker nodes? That's this approach that we selected at the end. And in order to deal with the complex network between the different regions, we use the Kube router as a CNI with IP encapsulation when routing the traffic through VPNs between the regions. In terms of network, you might notice that OVHcloud makes it possible to have various places where you can launch your virtual machines or have your dedicated bare metal equipment. And also they got a free and unlimited ingress and egress traffic, which is often not the case when dealing with a cloud provider. So rather than talking about hidden costs, let's talk about the 12 environments that the customer was dealing with. We had to implement a Greylog cluster with a dedicated Elasticsearch cluster behind it to deal with all of the remote bits and messages and logs coming from various clusters. Each environment within these 12 had a dedicated Prometheus non-persistent instance, and this was federated to a centralized, highly available Prometheus with federation enabled, and Thanos in order to archive long-term all of the different metrics. Another thing that was quite tricky, or not quite tricky, but a bit specific to the customer, was the numbers of registries that we had to deploy. So the idea was basically to have dedicated Docker image registries on each environment, and then to make sure that a developer would not be able to deploy directly in production anything. So the strategy that we went through was to have a pool replication model where the Arbor running in the production environment would pull from the staging environment the different Docker images, and this multiplied by the number of environments. Obviously, the staging Arbor registry would still be available for the developers to push directly, and also for the continuous delivery that was in place. In terms of results, so we had to deploy this over 6 different regions, which basically is equal to 12 different secured zones from a network standpoint, as we were dealing with staging and production. We had almost 40 critical applications per zones. Sorry, I got fleas everywhere here. And with the COVID, it's not simple to do this kind of video presentation. And all the logging and metrology was federated and centralized so that it was simple to ensure the right alerting mechanism. That's it for this third use case. Okay, to conclude this presentation, I wanted to state again that we are in partnership with OVHcloud. They provide a bunch of solutions when you want to run Kubernetes in the cloud. Obviously, they got the typical managed Kubernetes, but also a large choice of various equipments, bare metal, storage devices, as I said during this presentation, especially NVMe disks. Also, they got a predictable pricing, which is not usual when dealing with cloud providers. From an Enix standpoint, would be happy to help you tackle any kind of complex scenario. Obviously, our core business is to operate your clusters, any kind of cloud native application or Kubernetes clusters, but we can also help you with 360 audits and training. So if you got any particular scenario in mind and want to have a quick Q&A session with us during the KubeCon, please follow the links and meet us on the OVHcloud booth. Thank you and talk to you soon.